Hello guys, welcome to first law of thermodynamics, work expression plus indicator diagram. So suppose there's a thermodynamic system like this, and here we, we supply some heat dq to the system such that it goes from, well, let's say V1 to V2, and the small expansion is dV, and it is at a pressure P, volume, well, volume V1 already, and temperature T. So here, what is the work done? Well, work done is equals to force into distance, and here the distance is, well, small distance of dx, right? This is not this is the small distance dx. So here, what is force? Well, we know that pressure is equals to force by area, so force is just pressure into area, and here area into small distance dx, well, that's just the small volume occupied uh, by between V2 and V1, so this is PdV. This is the general work expression for a thermodynamic system, which we will have to use again and again in every or in most of the chapters. So now for indicator diagram. Now indicator diagram is a diagram which represents a thermodynamic system in any case. So this is the graph between pressure P and volume V. Now let's just say it was at initial condition I with pressure P1, with pressure P1 and V1. Now as we go along the thermodynamic system, it goes like this until, let's just say, I into the state F with pressure P2 and V2. Now let's just take any point, let's just say over here, let's call that S, and it will be at a pressure P and volume V, let's say. And what we do is we take a small distance dV, like let's say right here for example, which is, let's say, T with pressure P, because for a very small increase in volume, the pressure almost is constant. So here it will be pressure V plus, well, small change in V, which we'll write dV. Now let's draw a straight line to the or parallel to the pressure axis like this. This small distance is dV, of course. Now here, let's find the area of, let's just say this is S dash and T dash. So what is the area of S dash T dash T? Well, here, if this pressure is almost same and this is a small increase in volume, it is almost like a rectangle, right? Very close to a rectangle, so we can assume that this is a rectangle. So for rectangle, it's just length into breadth. So now here for the length, in both sides it is pressure, and for the breadth it is volume. So this is equals to PdV. So I'll just write it here, equals to PdV. Now this is a small part, a very small part of this, well, whole curve. So that means we'll have to integrate both sides. And I forgot to mention in the work expression that the work done, the small work done, equals to PdV, and if we integrate both sides, this is the total work done. It goes from V1 to V2 PdV, like this. And in this case also it goes from V1 to V2, right? And the same for this. Well, the integration of SS dash T, well, it is just the basics of integration, meaning that this is a small, very small part of the integration curve, and then, of the curve, and if we integrate this, we get the area under the curve, which is from I to F, which is, well, for volume, it is V1 to V2, right? So we get area of, well, let's just make a parallel to P axis again, M and N. Area of I M and F is equals to, well, this V1 to V2 PdV, which is equals to the work done, right? This one. So that means, well, the significance of the indicator diagram, which can be asked for your conceptual or just short questions, is that what is the significance of indicator diagram? Well, the significance of the indicator diagram is that the area under the curve from well, let's say one state to the another state gives the total work done. Well, yeah, gives the total work done for the system or in the system, let's say. And here numerically the area under the curve is equal to the total work done. That is the significance of indicator diagram. Please, if you have learned something new today, please like and subscribe, and thank you.